Your Ford rolled off the assembly line with a hidden countdown timer, hard-coded directly into its computer modules. Right now, as you sit at a red light or cruise down the highway, factory default configurations are quietly starving your critical components of oil, cooking your electronics, and accelerating mechanical wear at a rate that keeps dealership service bays full. You bought a Ford because you trusted the badge, but the engineers who designed it were answering to corporate bean counters and federal emissions mandates, not to the guy who has to pay the repair bill when the powertrain warranty expires. For 15 years, I have stood inside independent repair shops, tearing down blown EcoBoost engines and snapping photos of scored cylinder walls. I have personally inspected vehicles with less than 50,000 miles on the odometer that required total engine replacements, all because of settings the owners didn't even know existed. You think you are taking care of your vehicle by following the dashboard prompts, but here is what Ford doesn't tell you. Those factory settings are designed to help the vehicle pass government efficiency tests and survive just long enough to clear the factory warranty window. After that, you are entirely on your own. Let's look at the first hidden killer lurking inside your dashboard, a setting that is actively grinding your engine bearings to dust every single time you stop at a traffic light. I am talking about the factory-enabled auto start-stop system. To the EPA, this setting is a marvelous way to shave a fraction of a percent off fleet emissions. To me, as a mechanic who has to measure crankshaft end play with a dial indicator, it is a mechanical atrocity. When your engine shuts down at a red light, the oil pump stops spinning instantly. The pressurized oil barrier between your crankshaft and your engine bearings vanishes, leaving nothing but a microscopic film of oil. When the light turns green and the starter motor violently cranks the engine back to life, those heavy metal components experience metal-on-metal friction before the oil pump can even build target pressure. I have seen main bearings from modern Fords worn down to the copper backing before the truck even needed its first set of spark plugs. The solution isn't to manually push that little dashboard button every time you turn the key, because you will eventually forget. The real fix is a simple, plug-and-play electronic eliminator sleeve that installs behind the switch in less than 5 minutes, permanently reversing the default logic so the system stays off unless you choose to activate it. You save your engine bearings from catastrophic boundary wear, and all it takes is a simple 5-minute plug-and-play harness. Next, let's talk about a setting that is silently turning your engine oil into an abrasive slurry of unburnt fuel and carbon. The Factory Intelligent Oil Life Monitor. Look at your instrument cluster, and it will proudly tell you that your oil is perfectly fine at 10,000 miles or 12 months of ownership. I have drained oil at those factory recommend intervals, and it doesn't look like lubricant. It looks and smells like straight gasoline mixed with liquid charcoal. Modern direct injection EcoBoost engines suffer from an inherent mechanical phenomenon known as fuel dilution, where raw gasoline blows past the piston rings during cold starts and mixes directly with the oil in the crankcase. When you let that oil sit in your engine for 10,000 miles because a factory computer algorithm told you it was safe, that gasoline shears down the oil's viscosity until your timing chains stretch and your cam phasers start to rattle like spray paint cans. I have torn down dozens of 3.5-liter EcoBoost engines with jump timing, and every single one of them had a dashboard history of 10,000-mile oil changes. The fix doesn't require a master technician license or expensive diagnostic scan tools. You simply disregard the dashboard monitor entirely, manually reset it whenever it pops up, and establish a strict, unyielding physical interval of 5,000 miles or 6 months using a high-quality full synthetic oil and a factory motorcraft filter. While we are under the hood, we need to address the hidden electronic parameters governing your transmission's shift strategy, specifically what Ford calls adaptive transmission learning. Your truck or SUV features a sophisticated transmission control module that monitors your driving habits and constantly alters line pressures and shift points to maximize fuel economy. The problem is that the factory programming favors early upshifts to keep engine RPMs as low as possible. It forces your 10-speed automatic transmission to skip gears, jumping from first directly to third, and then lugging the engine in 10th gear at 45 miles per hour. This constant low RPM lugging creates immense torsional stress on the torque converter clutch, leading to a chronic shudder that eventually destroys the internal friction materials. I have personally inspected dozens of 10-speed units where the fluid was completely burnt black from premature clutch failure, all because the computer refused to drop down a gear when the driver pressed the accelerator. You can instantly bypass this destructive factory logic by shifting the vehicle into Tau.Hall or sport mode every time you drive. These factory-installed drive modes reprogram the transmission control module to utilize every single gear sequentially, increasing line pressures to ensure crisp, positive clutch engagement and eliminating the destructive gear skipping behavior entirely. But the hidden rot isn't confined to your powertrain. It extends directly into your vehicle's charging system through a factory configuration known as the battery age monitor and the smart charging system. Modern Fords do not charge your battery the way older vehicles did. To save a fraction of a horsepower from the alternator, the factory programming allows the vehicle's battery charge level to drop as low as 70% before it commands the alternator to step in. This leaves your battery in a chronic state of undercharge, which accelerates internal plate sulfation and causes premature battery death within 2 to 3 years. Worse yet, when you finally replace that dead battery with a brand new one, the computer still thinks the old, degraded battery is under the hood because the factory battery age counter hasn't been reset. It will continue to undercharge your brand new battery, killing it in half the time. I have seen owners go through 3 batteries in 4 years, blaming the battery manufacturer when the real culprit was the unreset factory computer monitor. The fix is a simple digital handshake using an inexpensive OBD2 adapter and a laptop. By accessing the vehicle's central configuration, you can manually reset the battery age parameter to 0, or better yet, reprogram the target state of charge from 70% up to 95%, extending your battery's lifespan from 2 years to 6. Finally, we have to look at the hidden danger built into your Ford's four-wheel drive system, specifically the factory electronic locking differential settings. Many truck and SUV owners believe that choosing a four-wheel drive model means the vehicle automatically protects itself from driveline binding. However, Ford's factory setting allows the electronic locking rear differential to remain engaged up to 25 miles per hour, even when making sharp turns on dry pavement if the switch is pulled out. When you turn a corner on high-traction surfaces with that differential locked, the inside and outside wheels are forced to rotate at the exact same speed. Because the tires cannot slip on dry asphalt, that immense rotational force travels straight up the axle shafts, twisting the splines and putting incredible stress on the differential ring and pinion gears. I have picked metal gear teeth out of rear differential housings because an owner forgot the system was engaged during a tight parking lot maneuver. The mechanical solution is total vigilance. Treat that locking differential knob like a loaded firearm, ensuring it is strictly pushed in and disengaged the millisecond your vehicle transitions from loose mud or snow back onto a solid road surface. These 5 configurations are just the tip of the iceberg when it comes to the hidden operational parameters that are quietly compromising your vehicle's longevity right out of the box. The automotive industry has shifted toward a model where vehicles are treated like disposable smartphones, designed to be driven for a few years and then completely replaced. But as a technician who values real mechanical durability, I know that you don't have to accept these engineered lifespans. There are still multiple critical control modules, hidden fluid schedules, and factory body configurations that are working against your wallet every single day, waiting to catch you completely off guard the moment your odometer ticks past that warranty line. If you thought bypassing the auto start-stop system or changing your oil at 5,000 miles was enough to save your Ford from an early grave, you are missing the most critical piece of the puzzle. In our last discussion, we broke down how those basic factory default configurations quietly bleed your battery dry and starve your crankshaft bearings of oil every time you hit a red light. Those are slow, progressive wear mechanisms. the kind that take years to manifest into a multi-thousand-dollar repair bill. But there is a second, far more sinister factory setting buried deep within your vehicle's engine control module that doesn't wait years to do its damage. This setting acts like a silent heart attack, capable of liquefying your pistons and snapping your connecting rods under the right driving conditions without a single warning light ever appearing on your dashboard. It is the single most destructive factory parameter I witness on a weekly basis, and it is a direct consequence of Ford's aggressive push to pull massive horsepower out of tiny, highly stressed EcoBoost engines. To understand why this setting is so lethal, we have to look at the physical reality of low-speed pre-ignition, or LSPI. This is a violent, uncontrolled combustion event that occurs inside direct injection, turbocharged engines when they are subjected to high loads at low engine speeds. Imagine cruising down the highway at 50 miles per hour in top gear. Your engine is turning a lazy 1500 RPM. You decide to pass a slower vehicle, so you press the gas pedal halfway down. Because the factory transmission strategy is programmed to hold on to higher gears for as long as possible to satisfy fuel economy targets, the vehicle doesn't downshift. Instead, the turbochargers instantly spool up, cramming a massive volume of dense air into the cylinders while the pistons are moving relatively slowly. This creates a high-pressure, high-temperature pressure cooker inside the combustion chamber. Before the spark plug can even fire, a microscopic droplet of engine oil mixed with fuel in the cylinder corner ignites spontaneously. This premature explosion collides violently with the piston as it is still traveling upward, creating an instantaneous spike in cylinder pressure that exceeds the engine's design limits by 300 to 400%. Here is where the factory setting transforms a mechanical vulnerability into a guaranteed engine failure. Your Ford's engine control module operates on a factory-programmed fuel mapping strategy that prioritizes an ultra-lean fuel-to-air ratio during these low-speed, high-load cruising conditions. The computer wants to burn as little gasoline as possible to keep emissions low and fuel economy figures high on paper. Under normal circumstances, a rich fuel mixture acts as a chemical coolant inside the cylinder. The excess fuel absorbs heat as it evaporates, keeping combustion chamber temperatures stable. But the factory settings deny the engine this crucial cooling mechanism. By forcing the engine to run on the absolute ragged edge of leanness, while the turbochargers are pushing maximum boost at low RPM, the factory computer creates the perfect thermal storm for LSPI to strike. It is the equivalent of letting someone slam a sledgehammer onto the top of your moving pistons while the metal is already heat-soaked to its melting point. I have seen the devastating aftermath of this setting firsthand on the floor of my shop more times than I care to count. Just last month, a customer towed in a 2021 Ford Explorer equipped with the 2.3-liter EcoBoost engine. It had just 62,000 miles on the clock, routinely serviced, driven primarily by a commuter who treated the vehicle with care. The owner told me he was simply accelerating up a moderate highway incline to merge into traffic when he heard a sudden, sharp metallic tink from the engine bay, followed instantly by a cloud of blue smoke out the exhaust and a total loss of power. When I pulled the vehicle into my bay and performed a relative compression test using an oscilloscope, cylinder number 3 showed 0 compression. I used a digital bore scope to look through the spark plug hole, and what I saw was a horror show. The entire ringland area of the piston had been completely blown apart. The extreme pressure spike from an LSPI event had shattered the hardened aluminum piston like brittle glass, sending razor-sharp metal fragments down into the oil pan and deeply scoring the cylinder wall beyond repair. That owner was forced to write a check for a brand new long block engine assembly. A catastrophe that was completely preventable if the factory computer hadn't been programmed to prioritize corporate fuel efficiency metrics over physical engine survival. The tragedy is that the fix for this hidden danger doesn't require tearing down the engine or spending thousands of dollars on aftermarket performance modifications. The solution lies in taking manual control over your vehicle's operating parameters to override the factory computer's destructive lean burn logic. First and foremost, you must change how you use your right foot when driving a turbocharged Ford. If you need to accelerate, pass a vehicle, or climb a hill, do not smoothly roll into the throttle while letting the vehicle lug in a high gear. You need to explicitly force the transmission to downshift first. You can achieve this by firmly dropping your foot to click the downshift paddle if your vehicle is equipped with them, manually selecting a lower gear on the shifter toggle, or simply stomping the pedal quickly enough to command a kickdown before the turbochargers build maximum boost. By raising the engine speed above 2500 RPM before subjecting it to high load, you mechanically eliminate the conditions required for LSPI to occur, because the pistons are moving fast enough to sweep the heat and pressure out of the chamber before an uncontrolled explosion can form. Furthermore, you can actively combat this factory setting by changing the exact chemistry of the fluids you introduce to your engine. The primary trigger for low-speed pre-ignition is actually the composition of the engine oil droplets that migrate past the piston rings. Calcium-based detergents, which were historically common in older motor oil formulations, have been scientifically proven to drastically increase the frequency and severity of LSPI events. To counter the factory setting's inherent risks, you must strictly use engine oils that are explicitly certified to API-SP or ILSAC GF6 standards. These modern formulations completely re-engineer the additive package, replacing volatile calcium detergents with magnesium-based compounds that inherently suppress pre-ignition. When you combine the correct oil chemistry with an active driving style that avoids low RPM engine lugging, you construct an impenetrable barrier around your combustion chambers, completely neutralizing the lethal lean burn parameters programmed into your vehicle at the factory. This hidden fuel mapping setting is the undisputed heavyweight champion of unprompted mechanical destruction. But the design choices that compromise your Ford's long-term survival do not stop inside the combustion chamber. The exact same philosophy of prioritizing short-term laboratory metrics over real-world, long-term durability extends outward into the cooling systems, the body structures, and the secondary mechanical modules that keep your vehicle operational. There remain several deep-seated engineering choices and structural vulnerabilities that continue to put your investment at risk every time you back out of your driveway, all of which are completely ignored by standard factory service manuals. We have unmasked the factory default parameters that are actively shortening the lifespan of your vehicle. We exposed how the auto start-stop system starves your crankshaft bearings of oil, and how the aggressive, lean burn fuel mapping forces highly boosted EcoBoost engines into catastrophic low-speed pre-ignition events that can literally shatter a piston inside its bore. Those two settings are brutal, frontline mechanical killers. But there is one final factory setting that is arguably the most deceptive of them all. This parameter doesn't announce its destructive intent with a sudden metallic bang or a smoking tailpipe. Instead, it plays a long, psychological game, keeping you completely blind to an active mechanical disaster until it is far too late to save your vehicle. I am talking about the factory-programmed buffering logic inside your instrument cluster's coolant temperature gauge. Look at the temperature needle on your dashboard once your engine warms up. It sits perfectly dead center, giving you a comforting sense of mechanical stability. You assume that if the engine were to start overheating, that needle would steadily rise, giving you ample time to pull over and shut down the engine. But as someone who has plugged thousands of diagnostic scanners into factory data ports while a vehicle is actively failing, I can tell you that gauge is lying to you. Modern Ford instrument clusters utilize a heavily buffered, software-driven algorithm rather than a true real-world readout. The factory programming is designed to lock that needle in the exact center position across an incredibly wide thermal window, typically anywhere from 180 degrees all the way up to 230 degrees Fahrenheit. The engineers did this because real engine temperatures fluctuate naturally during normal operation, and they wanted to prevent nervous owners from flooding dealership service drives with complaints about a moving needle. The mechanical consequence of this deceptive setting is catastrophic. By the time that dashboard needle finally unlatches from the center position and shoots into the red zone, your engine has already exceeded 235 or 240 degrees. At that thermal threshold, aluminum components expand at a rapid, uncontrolled rate. On Ford's four-cylinder EcoBoost engines, which feature an open-deck block design with thin cooling slits between the cylinders, this extreme heat causes the cylinder head to warp instantly. Once the head warps by even a few thousandths of an inch, the physical seal of the head gasket fails. This allows pressurized combustion gases to torch through the gasket material and enables engine coolant to flood directly into the combustion chambers. I have stood over countless engine bays, pulling cylinder heads off blocks, only to find the metal warped like a plastic toy left in the sun. The owners always tell me the exact same thing. The temperature gauge said everything was completely normal until the exact second the engine started sputtering and died. The factory buffering logic completely robbed them of the critical window needed to save their engine from total thermal destruction. This hidden thermal trap becomes exponenti, ally more dangerous when combined with another factory design choice, the transmission fluid bypass valve. Modern Ford 10-speed and 6-speed automatic transmissions utilize a thermal bypass valve designed to keep transmission fluid isolated from the cooling loop until the fluid reaches an ultra-high operating temperature, often around 200 degrees Fahrenheit. The goal was to get the transmission hot as quickly as possible to reduce fluid drag and scratch out another fraction of a mile per gallon for corporate fuel economy averages. However, this high factory thermal target accelerates the thermal degradation of the transmission fluid. It bakes the anti-wear additives right out of the oil, leading to premature clutch slippage, hardened internal seals, and valve body wear. Because your dashboard cooling gauge remains locked in its deceptive center position, you have absolutely no idea that your transmission fluid is cooked and your torque converter is operating in a state of chronic thermal stress until the unit begins slipping gears and hunting for shifts. When you synthesize all three of these factory settings, the bearing starvation of auto start, stop, dot, the piston shattering parameters of lean burn LSPI, and the blindfold of the buffered temperature gauge, the corporate playbook becomes undeniably clear. Your vehicle was configured from the factory to look efficient on government emission cycles and remain completely quiet during the initial warranty window. If you want your vehicle to survive long after the final payment is made, you must transition from a passive operator who blindly trusts factory programming into an active, proactive manager of your machine's mechanical reality. You cannot rely on the default settings to protect your investment. Your comprehensive shop floor survival strategy requires 3 immediate, unyielding actions. First, neutralize the electrical and electronic traps. Install a physical bypass harness to permanently invert the auto start-stop logic, and utilize your vehicle's manual select shifts or tow-haul modes to keep the engine spinning above 2,500 RPM whenever you demand high torque, effectively insulating your pistons from low-speed pre-ignition. Second, completely rewrite your maintenance schedule, throwing the factory manual directly into the trash. Change your engine oil every 5,000 miles or 6 months without exception, utilizing specialized API SP certified lubricants that suppress pre-ignition chemistry. And drop your transmission fluid and filter every 30,000 miles to flush out thermal contaminants before they varnish your control valves. Finally, tear off the digital blindfold. Invest in a simple OBD2 heads-up display or a digital monitor that plugs directly into your diagnostic port. This bypasses the instrument cluster's deceptive buffering logic, giving you a true, real-time numerical readout of your cylinder head and transmission fluid temperatures, so you can spot a cooling system restriction or a stuck thermostat long before the factory dashboard needle ever decides to move. The automotive industry wants you to believe that modern vehicles are black boxes, disposable electronic appliances that are far too complex for the average owner to understand or preserve. They want you to trust their factory monitors, follow their extended service intervals, and gracefully transition into a new vehicle loan the moment your current powertrain succumbs to these engineered limitations. But steel, aluminum, and fluid pressures don't care about corporate marketing or laboratory test cycles. They respond strictly to the laws of physics and mechanical friction. By understanding the hidden parameters operating behind your dashboard and implementing these targeted technician-backed corrections, you seize control back from the manufacturer and ensure your vehicle runs reliably for hundreds of thousands of miles. If you want to keep exposing the hidden mechanical traps that dealerships hide from you, and you want the exact, no-nonsense strategies needed to keep your vehicle out of my repair bay, hit that subscribe button right now and turn on notifications. Smash the like button if this breakdown saved you from a multi-thousand-dollar diagnostic mistake. And drop a comment below sharing the exact year and model you are driving so we can keep diving deep into the real mechanical truths the factory doesn't want you to see.